class. In our last class, we have established the structure of glucose through different chemical reactions and observations. Now today we are going to see the open and cyclic structure of glucose. So we'll try to draw the cyclic structure of glucose. That means in glucose in cyclic form, how we can write it as. So first what we have done is we have drawn the D form of the glucose. Okay, this is the D form of glucose, where you have got 6 carbon atom in a straight chain. Then the first carbon atom is aldehyde, then we have got 4 secondary alcohol and the position of OH in this way, and lastly CH2OH, which is primary alcohol. Now from this D glucose we'll try to draw the cyclic structure. Now what will happen, carbon number 1 and carbon number 5, okay, now this O will linked with this carbon atom as the bond breaks towards the oxygen. So when it breaks towards the oxygen, O will become negative and this carbon will become positive. So since this becomes negative, it will take this hydrogen and it form OH. So now there will be a two possibility, the OH can shift over here or towards left. Okay, now if OH is shift towards right, then on left hand side we have got hydrogen. Now at that time what will happen, this carbon will form a bond with the oxygen with the 5 carbon number, okay, in this way. This we call it as glycosidic linkage. We call this as glycosidic linkage. Or the other possibility can be the OH can be on the left hand side in this case and H on this side, and the carbon one will linked with the 5th carbon atom with the oxygen linkage. So when we have got OH at carbon number 1 on the left hand side, we call it as alpha D glucose, alpha. Whereas if OH is on the left hand side, we call it as beta D glucose. So from first glucose molecule we have drawn alpha D glucose and beta D glucose. This also a form of cyclic structure we can say, because if you see, then it has form a closed figure with 1 2 3 4 5 and this oxygen we can take it as 6. Okay, now we'll draw the pyranose structure from this. So for pyranose structure, the structure will be similar to pyrene. This is a heterocyclic compound where you have got a 6 membered ring, we can say. This is a 6 membered ring and we have got oxygen in the middle. It will be a similar because we have got a 5 carbon atom and oxygen in the middle, so the structure will be like pyrene. Okay, now from this we'll see how this has been drawn. So what we have drawn is first it has written in this form, okay, pyrene, general pyrene structure where we have got a 5 membered ring and oxygen atom. So in this way, now what will happen in this case, and after that we have number it, as since we have given the numbering to this thing, we have number it 1 2 1 1 2, okay, 3 4 5 and 6. Okay, you can see now at carbon number 1, if you see this one, at carbon number 1, H is on up, OH is down. So whatever you find on this side will be placed at the top, and whatever you find on this side it will be placed at the bottom. So the same thing is done at carbon number 1, H up, OH down. At carbon number 2, H up, OH down. At carbon number 3, OH up, H down, if you see this structure. And at carbon number 4, H up, OH down. And at carbon number 5, CH2OH has been placed up and H down. Okay, now this structure we can call it as alpha D glucopyranose because it's look like a pyrene structure. From in a similar way we have got beta D glucopyranose. In this case what we have done is once again we have drawn a 6 membered pyrene structure, and after that we have number it, and accordingly whatever you find on this side, okay, on this side it is kept above, and whatever is down it is kept below. So OH up, H down, H up, OH down, OH up, H down, H up, OH down, and CH2OH up, H down. So this will be a beta D glucopyranose. Now this alpha and beta form, the two cyclic hemiacetal forms of glucose differ only in the configuration of the hydroxyl group. At carbon number 1 they are called as anomeric carbon. the aldehyde carbon before cyclization. Such isomers, that is alpha form and beta form, are called anomers. Now if you see the structure of this and this one, alpha and beta, they only differ in the position of this OH at carbon number 1. In alpha we have got OH on the left hand side, and beta we have got OH on the right hand side. So such kind of isomers we call it as anomers. Okay, the 6-member cyclic structure of glucose is called pyranose structure. Alpha and beta in analogy with pyran, because it's similar with the pyran structure. Pyran is a cyclic organic compound with 1 oxygen atom and 5 carbon atoms in the ring. So pyran is a cyclic organic compound with 1 oxygen atoms and 5 carbon atoms in the ring. Okay, so now today's assignment will be, once again this will be, I think, assignment number 4, I believe, assignment number 4. Okay, so you'll draw this structure, the open and cyclic structure of glucose, even the alpha D and beta D glucose, and alpha D glucopyranose and beta D glucopyranose in your copy. That will be question number 1. Okay, and the second question will be, what are anomers? Okay, so you have got only the 2 questions for today's assignment. Okay, so please do that thing and send it in my mail.